stretching, shrinking, and reflecting graphs. So vertical stretch is what happens when you multiply the outside of your function by a number, as you can see here. So if we get back to our function, remember I said in the last lesson how vertical shifting was on the outside? Same thing for stretching. Anything that happens onto the outside of a function affects the vertical, affects the y values. So vertical stretch is when you multiply the outside of your function by a number bigger than 1. So it's kind of like slope. It multiplies all the y values by that number. So it stretches it vertically. So right here we're going to see what it does using absolute value. So I'm bringing out the decimals to try to use this way to see this. Let me make that a little bit smaller. And we want to graph absolute value, done. And then we're going to graph y equals 2 times the absolute value of x. And then y equals 3 times the absolute value of x. And y equals 4 times the absolute value of x. And when it's really easy to see when it's vertical, when something's a linear graph, because it's just like slope. If I expand it so you can see a little better, what do we want? Let's zoom in a bit. Y equals x has a slope of 1 over 1. You can see right there. You hit that 1 over 1. There we go. 1 over 1-ish. Y equals 2x? Well, all you did was multiply your y value by 2, so it should hit at 1 over 2. So instead of 1 over 2, 1 over 1, if I could ever get it. There we go. Oh, I was there for a second. There you go. You multiply your y values by 2, so you get 1 over 2. That's why the blue one's right here, at 1, 2. Over here, you multiply your y values by 3, so you get 1, 3. Kind of see, there we go. And then right here, you multiply your y values by 4, so you get 1, 4. So it's just like, when it's a line, it's just like slope. Right? If my slope was 4, I go over 1, up 4. So whatever the biggest number is, that's the steepest. Whatever the smallest number is, 1, it's the least steep. So we know each one of these, which one each one is. This is y equals 4 absolute value of x, y equals 3 absolute value of x, and y equals 2 the absolute value of x. And that's how you stretch it vertically. You multiply your y values by the number on the outside. Bigger than 1, it gets bigger. A vertical shrink does the same thing because, again, it's vertical, so it affects the y values. Just this time, that number you're multiplying your function by is small. It's something between 0 and 1. We don't talk about negatives. We'll talk about negatives later. Negatives do a separate thing than making it shrink or stretch. The number itself, that number in front of your function is less than 1, it makes it smaller, and between 0. And if that's bigger than 1, it makes it bigger. So we're going to do the exact thing here. We're going to look at what happens when we multiply x cubed by 0.5, 0.3, and 0.1. So let's bring up decimals again, and we're going to do all these values. We're going to do, what is that, 0.5, so x cubed times 0.5. And you can see the yellow there, the orange there, that it's moved, it's like multiply all the y values by 0.5. So this was at 1, 1, that's the normal one, 1, 1, and then you multiply the y value by 0.5, and it kind of shrinks, it gets smaller. So now it's at 1.5. If I do 0.3, multiply all my y values by 0.3, so that's going to be even smaller, right? So it was at 1, 1, now you multiply the y values by 0.3, now it hits that at 0.3. Well, it's working so much better than the last one I did. And then 0.1, so it's going to be 1/10 of the original one, so it's even smaller. Right, so the smaller it is, the kind of like the fatter it gets, or the more wide it gets. And then the bigger the number is, the skinnier it gets because it gets higher. But that's the idea. Basically, just multiply all your y values by this amount. So if you multiply by a small number, it gets smaller. Multiply by a big number, it gets bigger. And then so we can figure out which of those are which. In this case, let's see, y2 was the smallest, 0.1 x cubed, and then 0.3 x cubed, and 0.5 x cubed. So that's shrink. That's vertical shrink. Now, we can also do the same thing horizontally. Now, remember what I said about horizontally. That's one that's up on the inside. And don't forget, it's also the opposite. And that comes in play here. So, now, if I give you something like this. When it's on the outside, you just straight up multiply it. So, first of all, when it's on the outside, it affects the y values, and you just follow what it says, you multiply. When it's on the inside, it affects the x values, and you do the opposite. You're not going to be multiplying by 2. You're going to be dividing by 2. Opposite operation. So if the number is bigger than 1, you're dividing by 2. You get smaller. So it shrinks. If the number is a small number, like 1/2, so let's say you have like something like this. Well, now you're dividing by 1/2. So you have like a number like 3 and divide that by 1/2. Well, what happens? You multiply by the reciprocal and it gets bigger. So if you're dividing by a small number, it actually gets bigger. So horizontal stretch. So that's what happens horizontally. So we're gonna do this. We're gonna do that right here with this graph. So you can see. Well, first of all, here's the example, right? So you have a normal f of x graph. If I put a 1/2 on the inside, remember you're dividing by that. So your x's get divided by 1/2. So they all get bigger by a factor of 2. So that's why it's a horizontal stretch. So let's look at the one right here. So they want us to do it with this one. Here's our graph f of x. Do this to it. So the easiest way to do that is get our points. -1, -2, 0, 1, 2, and -1. And then remember this, notice how it's on the inside, so it affects our x value. And we do the opposite of what it says. So we're not going to multiply by 1/2, we're going to divide by 1/2. Well, dividing by 1/2 is the same thing as multiplying by the reciprocal. So basically we're multiplying by 2. So we're multiplying our x values by 2. So we're going to come here, we're going to multiply our x values by 2, multiply x values by 2, multiply our x values by 2. And we get -2, -2, 0, 1, 4, -1. So those are our new points. Let's plot them. -2, -2. 0, 1 didn't change. And then we have 4, -1. So it looks like this. So you can see that was a horizontal stretch, right? It stretched horizontally. So it went from there to there and there to there. So that's how we do stretch. For me, that's the easiest way to do stretches and shrinks. Just what does it do to your points? If it's on the inside, it affects the x values. You do the opposite. If it's on the outside, it affects the y values, and you just multiply. You multiply your y values by those numbers. And that's how it works. We skipped this earlier. So what do the negatives do? They kind of do the same thing. So a negative on the outside is like multiplying all your y's by -1. So that's going to flip it up and down. So I like to call it, so if you see negative f of x, I like to call that a vertical flip. Because it flips vertically, right? You multiply your y values by negative. Well, first of all, it's on the outside. That affects the y's, which is vertical up and down. So it's a vertical flip. So if it looks like this, now it flips and looks like this. So you're flipping across this x-axis, which that's what most people say. Most people call this an x-axis flip. I like to say, or x-axis reflection. I like to say it's a vertical flip because you're flipping it vertically up and down. When the negative's on the inside, well, inside affects the x values, and you do the opposite. You're dividing by -1, but it's the same thing as multiplying by -1, so it works the same way. So I call that a horizontal flip. So you could kind of see right here my shortcut things in the way. But that's a horizontal flip, right? Left and right. So that's what the negatives do. Right? Negatives don't do anything else. If you see a negative, it just flips it. If I say like a -2, so if I gave you this, that's two separate things to me. There's a vertical flip, and then there's a vertical stretch. Right, so that's all we care about in the negative. The negative just flips it, that's it. The number next to it does a stretching or shrinking. So let's do an example here. Sketch the graph of y equals negative f of x. So we're going to do that here. Actually, can I do this? Let's do some magic. I need two of them. I'm going to do two of them. There we go. Nice. Okay. I need a different color. I want them contrast. So let's do this one first. Let's do y equals negative f of x. So keep in mind the negative's on the outside, right? So it's on the outside, and outside affects the y values. So that's like vertically. So we're calling this a vertical flip. If you want, you can also think about it just like, oh, I'm going to multiply my y values by a negative. So it becomes 0, that becomes 3, that becomes -6, that becomes -6. So either way you want to do it, it works both ways. So I'm going to do a vertical flip. So it's going to be like this is a hit up there, That's going to be down here. Down there. It's going to look kind of like this. So it's going to flip vertically across this line. Not perfect. I probably should have done the points. That's kind of what it's going to look like. Now let's do this one. It's on the inside. So inside is the x values, and that's horizontal. So this is a horizontal flip. Or if you want, you can think about it as we're going to divide all our x values, remember inside opposite, by -1. So we're going to divide all our x values by -1. I'm going to do it this time because the thing looks a little nicer. So our points are these. Right? And again, since all I see here is we're dividing our x values by -1. So if we divide all these by -1, inside opposite, I get 4, 0, 1, -3, -2, 6, -7, 6. So 4, 0, 1, -3, -2, 6, -7, 6. It looks something like that. So you can kind of see it flips left and right. This one flips up and down. So that's what the negative does. It just flips it. If it's a negative on the outside, it flips the y value, so it's a vertical flip. If it's a negative on the inside, it affects the x value, so it's a horizontal flip. Now let's combine it all together. So we're going to combine it all. Now the way you do this is order of operations. Right? PEMDAS, please excuse my dear Aunt Sally. All that means is we're going to multiply before we divide. Before we add and subtract. Right, so multiplication comes first before, we're not going to do parentheses next one, but we multiply before we add and subtract. So look at this. We want to describe what's going on for A. So generally, actually before that we reflect. So we're going to do a vertical flip. Also known as an x-axis flip. Then what happens? We multiply before we add. So we're multiplying our y values by 3 because this is on the outside. So we call that a vertical stretch of 3. Because again, it's on the outside, so vertical. And it's bigger than one stretch of 3. Again, right? So remember, the negative is its own thing. It's a flip. So it's either flip on the inside or the outside. This is on the outside, so vertical. The number, since the number bigger than 1, it's a stretch. And it's on the outside, so vertical stretch. And then let's do the shifts. Those don't matter because we're adding, so it doesn't matter. So we're moving 4 to the right and 5 up. So translation, we call that. Or shift, either one's fine. 4 to the right, inside opposite, and 5 up. So that's how you describe A. You go like, well, there's a vertical flip to negative. There's a vertical stretch because the 3 is on the outside, and so that's the y values. Inside, opposites, we're moving 4 to the right, and 5 up. B. Give it the equation of a function that who would be obtained by shifting the graph of y equals square root of x, absolute value of x, sorry, to the left 3 units, vertically shrink the graph by applying a factor of 2/3, and reflecting across the x-axis, and shifting the graph 4 units downwards in that order. In that order, sketch the graph. So they want to give me an equation. They want me to give the equation, then sketch the graph. Okay. So our basic one is this. Okay, so we'll move left 3 units. So it's going to be square root of x plus 3 inside opposite. They want to vertical shrink the graph by applying a factor of 2/3. I should write this a little nicer. So I'm going to put 2/3 on the outside. Right, because that's where vertical stretch goes. Vertical shrink because it's less than 1. So since it's vertically, it's on the outside. Reflecting across the x-axis, that's another way of saying a vertical flip. So it means there's going to be a negative on the outside. And shifting the graph 4 units downward. So on the outside, again, up and down, it's on the outside. 4. Don't forget my y equals. And that's my equation. And now they want me to graph it. So we'll just kind of follow, where do we want to start? Remember, where do we start? -3, inside, opposite, outside, follow. So we should be starting at -3 and -4. -3, -4. And then the fact that it's negative means it moves down. Now this is a line, so really we could just treat it like a slope. We're going to go down 2 and right 3. So we're going to go down 2 and right 3. Since it's an absolute value, we're going to do the same thing on the other side. Down 2, left 3. It looks like that. So that's how it looks. Describe how the graph of y equals absolute value of negative x plus 1 can be obtained by transforming the graph of this. So this one's a little tricky. I put this one here on purpose. We can't have a negative in front of the x if there's a plus 1. So what we have to do here is factor it out. Because right now it looks like, oh, it's a horizontal flip, and then we have to move left 1. That's a little bit of a lie. You got to factor out the negative 1 first. So it looks like this. And now we could go, oh, so there's a horizontal flip, and we move right 1. So that's what's going on here. So you have to do a horizontal flip, or flip across the y-axis, and then shift right 1. I'm going to sketch the graph. So we're going to go 1 to the right, only 1 to the right. It's a horizontal flip, so horizontal flips with absolute values don't really do much. So, right, an absolute value looks like this. If you flip it horizontally, left and right, it's an even function, so it looks exactly the same. So that part looks exactly the same. So you get that. Now again, you can always check your work using Desmos or graphing calculator. Right, I subbed in the original function, and we get the exact same graph we got. Right, crosses that 1, looks like that. There we go. Next one. Recognizing a combine of transformation. Shows the graph. So this right here, we have a graph of the blue one, right? That's the original y equals absolute value of x. And then we have a red one here that does some combination of shifts. They want us to find the equation of the red one. Okay, so first thing I'd like to find out is how did it move? How did it shift? You get away from there to there, right? So we normally start at 0, 0. We went to what? Right 3 and 3 and down 2. So remember how we plug that, how we rewrite that as an equation? Inside's opposite. So right 3 would be a positive 3, but we do the opposite on the inside, right? Inside moves left and right, so it'll be a minus 3. And outside we follow. So when down 2 is a minus 2 on the outside. And then this guy right here in front, it's like the slopes. We're dealing with lines, it's pretty much just a slope. So we just got to find the slope of this guy. And the way we're going to do that, we start here, we end there, so we do a rise or run. Ran 1, and we went up 3. So my slope there is 3. Right? Go over 1, up 3. So that's my vertical stretch. And there we go. So you find out where you start, inside, opposite, outside, follow. And then to find out what the vertical stretch is, you do the slope. Because it is a line, so you just do the slope. It works out like that. Next one, write an equation x and y that results in the desired transformation. The cubing function vertically shrunk by applying a factor of 1/2. So you notice how it's vertical? Again, vertical is outside. So cubing function is x cubed. So we're going to do y equals 1/2 x cubed. And there we go. A cube root function reflected across the x-axis. So reflected across the x-axis, here's your x-axis. So you're flipping across there. That's a vertical flip. So that means it's a negative on the outside. So cube root would be this. And then we flipped it across the x-axis. We flipped it vertically, so it affects the outside. So there's our graph. Next one, the absolute value function vertically shrunk by applying a factor of 1/3. So remember, vertical is on the outside and reflected across the y-axis. So absolute value function looks like this. On the outside, we're going to put a 1/3 because it's a vertical. So 1/3 on the outside. Now this one reflecting across the y-axis. That's a horizontal flip. So that means the negative's on the inside. So it looks like that. And the last one of these, the square root function vertically shrunk by applying a factor of 0.2 and reflected across the x-axis. Remember, reflected across the x-axis, that's when you see the most. That's a vertical flip. So it means we put a negative on the outside. So it's something like this. Square root function looks like that. We'll put a 0.2 on the outside because again, it's vertically shrunk, so on the outside. And then we put a negative on the outside also. So that's what that graph looks like. Next one. Use transformations of graphs to sketch the graph of y1, y2 by hand. Check the graphing calculator. So we're going to graph these by hand real quick. So this first, I'm just going to do that on black because it's It's a normal 1, 1 graph. It's a normal one. Again, anytime it's a line, you just want to treat it like a slope. So that's like a slope of 1. So I'm going to go right 1 over 1. Start at 0, 0, go right 1 over 1. There we go. The next one, there's a 2 in front. So that's a vertical stretch of 2. Again, it's a line, just treat it like a slope. So we're going to start at 0, 0 again because there's no transformations. And we're going to go over 1, up 2. Left 1, up 2. Again, it works perfectly if it's a line. The next one, 2.5, I guess we'll do the same thing. So we're going to start it with 0, 0 because there's no shifts or transformations. We'll go over 1, up 2.5. Left 1, up 2.5. So it looks like this. There's our graph. Next one, y equals 3 minus x. So I'm going to rewrite this to make it a little bit nicer to read. This is same thing as saying negative absolute value of x plus 3. So that's what's going on here. We're doing a vertical shift of 3, moving up 3, but we have to flip it. Now we generally do flips first, so we know our graph opens down. That's all that stands for. So if I'm doing a graph here, we're going to go 1, 2, 3, and then our graph opens down, the slope of 1. So it's like over 1, down 1, over 1, down 1. So that's the first one. Next one, we do the same thing, rewrite it for us, 3x plus 3. So we're starting at 3 again. And it also opens down. Now there's a 3 on the inside. Now, so that's the minute we're going to divide our x values by 3. So one way to look at this is like, normally here we go 1 over 1, down 1. Well, here, remember our x gets divided by 3, so we're going to go over like a third and then down 1. So it's kind of like this. Then we'll go over a third and down 1. So it looks like that. Because that's a horizontal shrink. We shrunk our x's by divided by 3. So normally you go over 1, down 1. But in this case, since we're dividing our x's by 3, we're going to go over a third and down 1. It looks something like that. The next one, again, rewrite it so we can see it a little better. So it's going to be y equals negative 1/3 x plus 3. So we'll start at 3 again. Now this one, remember what happens here. It's the opposite. We're dividing our x's by 1/3. Well, that's the same thing as multiplying your x's by 3. So how before we went over 1, down 1, now we're going to go over 3, down 1. Because we're multiplying our x's by 3. So over 3, down 1, give me something like this. Ish. That's not my best graph, but that's kind of the idea of what it looks like. Again, we can check our work using decimals or a calculator. I want to check if I'm right or not. So this would be 3 minus absolute value of x. Right, so pretty close. That's what mine looks like. The next one, y equals 3 minus absolute value of 3x. And you can notice that the red one is the second one. For me, that's the blue one. And yeah, pretty much, right? Like I said, it's like normally you would go over 1, down 1. But this one divides your x by 3, so you're going over like a third and down 1. It's like right there. See 0.331. And then the last one, not to show off, just good at math. Y equals, let's see, what is that? 3 minus absolute value of 1/3 x. Right, and you get a graph like that, you get the blue one that matches our purple one. Right, so like I said before, right, you're multiplying your x's by 3, so you're going over 3 and then down 1. So you can see right there, right, they went over 3 and down 1. Because that's what it does. Okay, the next one, same idea, we're going to do that one just a little faster. First one, cube root of x. Cube root of x looks like this. It's a basic one. Done. The next one, again, I'm going to rewrite it to make it so you can see that a little better. That's negative cube root of x plus 2. So we're going to go up 2, then to negative cube root of x. So we're going to flip it upside down. So instead of going like this, like going from left, going up and down, like increasing, we're going to be decreasing. We're going to flip it. So it's kind of like this. Again, not perfect, but the general idea. I should be more centered. Oh, I don't like that. It's like a square root function going this way and a square root function going this way. There we go. I feel much better about that. I know it looks mostly the same, but whatever, it makes me feel better. Next one. Again, let's rewrite it. Oh, you don't have to rewrite it. My vertical all I'm going to do is move it up 1. That's it. So it's going to be right here. then it's the exact same graph as the first one. And you get something that looks like that. Okay, next one. Each figure shows a graph of y equals f of x. So this is y equals f of x, our basic graph. Sketch by hand the graphs of functions a, b, c, and attribution d. So I want us to sketch by hand this guy. Now, anytime I think I talked about this before. Anytime I have a graph that's like a graph, like they don't, it's not one we're supposed to know. I use the points to be my guide. So -4, 0, -2, 3, 2, 1, and 6, 1. Right? I use that to be my guide. Now for a, we'll do this in blue. Negative f of x. Remember what that does. So you can do it two ways. You go, okay, I know what this does. It's on the outside, so it's a vertical flip. It's going to flip my graph vertically. So it's going to look something to this effect. Ish. Again, I can't draw, but it's in that effect. You can do that, or just do the math. Do the math for just the points, right? What this does is on your y's, it multiplies by -1. I think I should do this. There we go. Right, because it's on the outside, you're multiplying by -1. So if you get all these points and on your y's, you multiply by -1, you get -4, 0, multiply that by -1, you get -2, -3, multiply the y by -1, 2, -1, 6, -1. So if I graph it just with that, using that in mind, I still start here. I go -2, -3, I go 2, -1, and then 6, -1. So I guess it looks like this. It's a little better. Again, so I don't have the grids down here, so I can use that. But there's two ways to do it. Okay, that was A. I'm going to erase it now because I need to do other things. Okay, let's do B. F of -x. Okay, what does that do? Well, one way it does it, right? If you don't understand what it's doing, it's on the inside, so it's going to flip it horizontally. So flip it left and right. Now, this one's actually tougher for me in general to do that. Or you can do mathematically, you're just dividing your x's by -1. So you get all your x values and divide them by -1. Remember, inside opposite operation, -1, not just 1. So I get 4, 0. I get 2, 3. I get -2, 1. And I get -6, 1. So it looks like this. Again, my head was not steady there. That was an ugly, ugly graph. Listen to that effect. You can kind of see it. It flips this way. Not the artist, so sorry, but that's what it does to it. Okay. Next one. Let's do that purple. C. Y equals 3f of x. So what does this do, right? It's a vertical stretch of 3. Remember, it's on the outside, it affects the y values. And all we're going to do here is multiply by 3. So we're going to multiply all our y values by 3. That's what's going on here. So multiply this by 3, multiply this by 3, multiply that by 3, multiply that by 3. We get -4, 0, same point. You get -2, 9, -2 and 9. So all the way up there. You get 2 and 3. And we get 6 and 3. So it looks like this. So that's a vertical stretch of 3, right? We multiply all our y values by 3. Last question, what is f of 4? That's like a throwback. F of 4 is just what's the y value at 4. So here's 1, 2, 3, 4. Just the point right there. And that point is 1. Right, it's all that does. Anytime f of 4 is saying, what's the y value at that x value? Okay, almost done. The graph of y equals 0.5 rad 3 x plus 2 can be attained by the graph of y equals f value of cube root of x by shifting horizontally 2 units to the left, 2 units to the left, right, inside opposite, and shrinking vertically by a factor of 0.5, right? The vertical shrink is again on the outside. So there we go with that one. Now, the last thing here we're going to do here is just graph these just real quick. Okay, so this first one. Again, I like to have the negative in front. Not the negative, but I like to have the actual function in front so you know what we're talking about. So look what's going on here. We have the absolute value function, no, sorry, the square root function, which typically looks like this. That's a normal one. We're going to flip it upside down. That's what the negative outside does. It flips it upside down. And we're going to move it up 1. So we'll move it up 1. Right? Vertical stretch of 1. And then we're going to flip it upside down. So it looks like that. Right? There's a vertical flip and then a vertical shift of up 1. The next one, oh nice, I already factored it for us. So this is another square root function. So another one that looks like this. This one actually has a flip on the inside. So I'm going to flip it left and right. So our graphs, instead of looking like this, it's actually going to flip the opposite way. It's going to look like this. We're going to flip it left and right. And then don't forget, we have to move it. In this case, we're moving it left 1. Inside opposite, moving it left 1. So we're starting right there, and we're going to open to the left. Because that was a horizontal flip. A flip on the inside moves it, flips it left and right. So it looks like this. And then finally, this one they didn't factor for us, so we got to factor it out ourselves. We can't have a negative in front of the x. X has to be by itself. So that tells us everything now. So now I know it's a horizontal flip left and right. That really doesn't do much for our graph because it is an absolute value, so it looks the same either way. But we do have to move it right 3. Looks like this. And there we go. That's the lesson.